Hi friends, welcome to lesson 8 of our distance learning. Sorry, my phone just went off. I'll keep that in there just so you know I'm human. But just want to let you know, continue to miss you guys. Make sure you're reaching out if you need anything. These skills are things you're going to be using next year. We continue to be doing pretty well. It's been great. Spend a lot of time outside when I'm not working, and it was pretty cool. Today I had a Zoom meeting and I wore a shirt and tie and Under Armour shorts. So that was pretty cool. I was looking for an opportunity to do that. But really missing you guys, missing being in the classroom, and I'm looking forward to the day that I get to see you all again. Hopefully we can like high five and stuff whenever that does happen. But we're to jump into the math. Fancy words again for what we're doing. We are going to be factoring out a monomial from a polynomial. So to put it in some simpler words, we're going to divide out the biggest thing we can from an expression. So there's going to be a lot of numbers thrown around, a lot of variables thrown around. I want you to stick with what you know, and principles of exponents in mathematics you already know. So this is it's going to look like a new thing, like you maybe have never done what we're doing before, but you have all the skills and knowledge to do it already. So don't be afraid to watch the video twice. Don't be afraid to go slow, make mistakes on the homework and change them the right way. And again, lean on those office hours if something's not right, because you're not alone. I got you. So let's get into it. So factoring out a monomial from a polynomial. So here's an expression, and really we're going to be looking for the greatest common factor, or what's the biggest thing I can divide from both of these. So I like to start with the coefficients, and I've got a 30 and a 20. The biggest thing I can factor out of 30 and 20 is 10. So I'm going to put that out front of my expression. Okay, I know I can divide both of these terms, this term and this term. I know I can divide them both by 10. The next thing I'm going to look at is my variable, and in this case I got an x to the 5th and x cubed. Both of those have a factor of x cubed. So let me prove that in a little thought bubble up here. X to the 5th is 1, 2, 3, 4, 5 factors of x, and I don't know why I'm doing it like division like that. And x cubed is x times x times x. So they actually both have an x cubed in common. So that's why I'm going to divide out or factor out an x cubed. See, x to the 5th has x times x times x. X cubed has x times x times x. So I'm going to throw that term out front. That's my monomial. Then in parentheses, so it's kind of like we're undoing the distributive property right here. So I'm going to focus on this term. When I divide 30 by 10, I get 3. And when I divide x cubed by, or x to the 5th by x cubed, I get x squared. So you might remember, x to the 5th divided by x cubed, 3 of these factors of x cancel 3 of these factors of x. That's where I'm getting this x squared right there. All right, and then I've got a minus here. So now I'm going to be working on this term. 20 divided by 10 is 2. And x cubed divided by x cubed is x to the 1st. So I'm just going to leave it as a 2. And that would be my answer. So it's the same expression, but now I have a monomial and a binomial. And when we get into quadratics, you're going to see why this is useful. We're going to be able to solve quadratics by factoring much quicker than using the quadratic formula. So this is a skill that's really going to help things be efficient in the future. Another way you can test this is by imagining yourself redistributing your problem. So if I distribute, I get 30x to the 5th, check. If I were to distribute, I get negative 20x cubed, check. So this right here is my answer. And again, there's numbers and stuff, numbers and letters kind of being slung everywhere. I want you to lean on concept, and I want you to lean on what you know, all right? And don't be afraid to go back and watch that again. All right, this one is a little simpler. If I look at both of these terms, I'm looking for the biggest thing I can divide them by. So I'm looking at coefficient first. I got a 12 and a 4, and there is a factor of 4 there. You could also think about factoring out a negative 4, and you could. So let's do it both ways. If I divided this term by 4, I get negative 3x. If I divide this term by 4, I get a 1. And so let's check that. If I were to, so we're undoing that distribution. If I was to distribute, I get negative 12x. And if I was to distribute, I get plus 4. So let's look what that looks like if I factored out a negative 4. So if I divide my first term by negative 4, I'd have 3x. And if I divided my second term by a negative 4, I'd have a negative 1. So it's the same thing, just it's the inverse of my positives and negatives. I personally lean toward this one, but they would both be mathematically correct. Okay, so this one, if I look at my coefficient, I got a negative 1 and a 6. So you could look at factoring out a negative 1 if you wanted, but there's no reason that we have to mess with the coefficient here. So really we're going to be looking at this variable. The most that these have in common are one factor of x. And here's how I do that. I pull one factor of x out in front of my parentheses, and then I'm going to divide both terms by x. When I divide this first term by x, one of my x cubes would cancel, right? Remember, x cubed is x times x times x. I divide by an x. One of those would cancel. I'd be left with negative x squared y, so just one factor of x left, plus 6. Also, 6x is one factor of x less. And if you want to think about that 6x divided by x divided by x is 1. That's why it just leaves me with 6. So I remember when I took algebra in 8th grade, finding it useful to really think about, like, what's the biggest number I can suck out of that number? And then I also thought about it as the inverse of distributive property a lot. Those are two things that helped me when it really clicked. So 4, you're going to see we have 3 terms here in this polynomial, 5th degree trinomial. And I'm going to look at my coefficients, and I'm hoping you see that that factor of 5 is popping. It's a Jack Harlow song. Don't listen to it. Okay, so 15, 10, and 5 all have a factor of 5. And let's look at our variable. I have one factor of x in everything. Remember, x to the 5th has at least one factor. So you can kind of find the smallest variable and use that as the highest number of factors of that. So I can also divide everything by x. So I can divide all 3 terms by 5 and x. And I just do it one term at a time. I look at the first term. So really, what we're doing for that first number inside of our parentheses is 15x to the 5th. We're dividing out that 5x. We're pulling a factor of 5x out. And that's going to give me 3x to the 4th. So if you look at it down here, divide by 5, divide by 5, divide by x, a factor of x, that leaves me with 4. We'll look at the second term. That's going to give me 2x squared. And what's happening there is this. I'm dividing 10x cubed by 5x. 5 and 10 simplify to 2. One factor of x left, less one factor of x left. So there's that 2x squared. And now that third term, anything divided by itself is 1, but it's minus, so negative 1. What's happening there is negative 5x divided by 5x. There's my negative 1. There's my 1. So it has to be a negative 1. And then again, you can always check your answers by remultiplying your monomial by a trinomial there. All right, the last one looks crazy, but just stay with me. Let's lean on what we know. Let's lean on the principles, okay? So I look at my coefficients. I hope you're all seeing that 7, that factor of 7 pop. And then let's look at the x's. The least number of x's of any term is one factor of x, right? There's 1 there, 3 there, 5 there. So they all have at least 1. And looking at y, I have 1 factor, 2, 3, 2. So at most I have 1 factor of y as well. So what I'm going to do is I'm going to take all 4 of these terms. This, if you're wondering, is a 7th degree polynomial. When we have this, we can divide all 4 terms by 7, x, and y. So that's what we're going to do. We're dividing out a 7xy. I'm looking at this first term here. If I divide by 7, I get 6. X divided by x is 1. Y divided by y is 1. So that's just 6. Looking at my second term, I get a negative 3. X divided by x is 1. And y squared divided by y is y. Looking at my third term, 14 divided by 7, that's going to be a negative 2. X cubed divided by my x is going to give me x squared. And y cubed divided by my y is going to give me y squared. Guys, number 5 would be a good one to look at twice. There's a lot going on here. And I'm looking at my fourth term now. Negative 42 divided by my 7 is negative 6. I got x fifth divided by x for x to the fourth. And I've got, I don't know what that beep is. Okay, I've also got y squared divided by that y to be a y. So again, all I did was I divided out a 7xy, or the greatest common factor from all four of those terms. And I've got this expression, a monomial and a polynomial left over. So guys, I miss you for real. Been thinking about you a lot. Hope everybody's doing well, and I mean it. Lean on those office hours. Lean on failure. Getting some. I don't expect you to get this all right. You know, this is tough stuff, and we can't work in the nitty gritty like we can in the classroom. You know, where I kneel down next to your desk and work right with you. You know, we're dealing with a different set of circumstances here, so make the most of it. I want you to know I'm working hard for you, and hope to see some of you on Friday at those office hours. Be good.